All right, so thank you everyone for joining the session. You are listening to myself, Aftab Siddiqui. I work for Internet Society and be part of a project called MANRS, which is Mutually Agreed Norm for Routing Security. Today we'll be talking about a very important project, at least for myself. I've been using it for a very long time. And if you're a network engineer, then you must be very familiar of it. If not, then well, you're at the right place. So we'll be talking about a project called RouteViews. It's a project funded by Advanced Network Technology Center at the University of Oregon. And with us, we have to discuss this is David Teach, who's a network architect at the University of Oregon, and our very own Dr. Philip Smith, who's been teaching BGP for as long as I can remember. And being part of the NSRC, he's an active user and a important teacher for us to let us know in the future that how we can use RouteViews as well. So I'll hand it over first to David to take it from here.
Great. Thanks, Aftab, for inviting us here to present, and also, thank you to ISOC for giving us this opportunity to talk with you all about some of the things that we're doing with RouteViews. Let me go ahead and share my screen. And can you guys all see that?
Yes.
Great. Okay. So RouteViews monitoring infrastructure. This is essentially going to be a talk about some of the new and interesting things that we're doing with our collector platform. So what is RouteViews? RouteViews is a collaborative routing looking glass to share BGP views among network operators and researchers. We were founded at the University of Oregon, as Aftab mentioned, in the Advanced Network Technology Center in 1995. We have data archives that go back to 1997. And we have about 32 terabytes of compressed routing data today. The group is currently led by network engineering team at the University of Oregon. That's me and some other folks, with assistance from the Network Startup Resource Center and folks like Philip Smith. NSRC, or the Network Startup Resource Center, supports the growth of global internet infrastructure by providing engineering assistance, collaborative technical workshops, training, and other resources to university research and education networks worldwide. The NSRC is partially funded by the IRNC program, the NSF, and Google, with other contributions from public and private organizations. And the University of Oregon is a public research institution in Eugene, Oregon, founded in 1876. The U of O is renowned for its research prowess and commitment to teaching. And both the NSRC and RouteViews are based at the U of O. So now that we've kind of got that information out of the way, here's kind of a rough snapshot of where RouteViews has a presence at various exchanges around the world. And there's also some multi-hop collectors in here, which we will talk about here in a minute. This isn't by all means exhaustive. I'm trying to keep the slide from being too much of an eye chart, but it gives you a general overview in terms of the coverage that we have today. So some peering statistics for us, and these were driven from the last time we took a snapshot. But we see about 264 million prefixes advertised to us from 745 peering sessions from 288 unique autonomous systems. And the link down below is to the updated page when we do post those new peering stats. So what are our collectors? They're basically off-the-shelf commodity hardware. We look for anything from 8 to 16 cores, anywhere in the 32 to 64 gigs of RAM range, 400 to a terabyte worth of disk, and 1 to 10 gig Ethernet for our transit and peering interfaces. So not by any means a large hardware footprint there. On the software side, we use a mix of CentOS as the Linux OS, and then we also deploy on our older collectors Quagga, BGPD, which is the BGP daemon that is actually your peers are peering with. And also on our more modern collectors, we use FRR, which is actually a fork of Quagga. We do have one vendor supplied collector. It's a Cisco ASR 1004 and it runs iOS XE. So what are the different types of peerings that we can accommodate with RouteViews? The first and most easiest peering is the multi-hop peering. And what's great about this is if you have an AS and a BGP speaking router and you can reach one of our collectors, you can peer with us and start sending us your routing data. The downside to this type of peering is these peerings are subject to the routing anomalies that we're looking to observe and collect. So if there's a BGP issue in the path between your router and our collector, we might not actually see what happened from that multi-hop session. Versus the IX peering model, where we actually have a collector with an interface onto any of those internet exchanges that we listed a couple of slides back. And what's nice about this is we're better positioned to address any of the multi-hop issues. We have geographic diversity, which gives you a better local, regional, and global view of what's going on in the global routing infrastructure. And it also provides much better peering diversity. Our collector data is based on an RFT standard called MRT, or Multi-Threaded Routing Toolkit. MRT provides a standard for dumping routing information into a binary format. And essentially, we use that binary format in RouteViews to dump BGP RIB tables every 2 hours and BGP update messages every 15 minutes. We then take that MRT binary file and we bzip it and rsync it back to our data collection server, archive.routeviews.org. And that's regularly synced every time that we see a new update or RIB file. And those files can be accessed via HTTP, FTP, or rsync. There's a number of different tools out there that you can read this MRT data with. I've listed a bunch of them here. I'm not actually going to go through all of these, but I will highlight the second from the bottom tool here, BGP Stream. That's a set of tools and libraries developed by CADA, which is a research group here in the US. And it does a very good job of parsing that MRT data in a very unified, user-friendly format. And we're actually going to see some examples of BGP Stream here towards the end of the presentation. So what are the different use cases for RouteViews? On the operations side, I think everyone that's on this call probably understands the importance of the global routing infrastructure and the role that BGP plays in it. And it's really up to us to ensure its stability and operation. And it needs to be constantly monitored in order to do that. RouteViews helps provide some of those tools to accomplish that by providing a command line looking glass interface. We also provide prefix visibility. You can verify convergence. You can look at path stability. We're also able to give you, as I mentioned, different views from a local, regional, and global view of the routing table. And it being an open CLI, you're able to do a lot of different troubleshooting techniques to get that BGP information you need to address your issue that you might be running into. On the research side, there's a lot of interesting things that we see in BGP and that I think researchers are trying to address in BGP and the global routing infrastructure. A couple of those examples are network topology monitoring, the likelihood of route leaks and hijacks that we've started to see in increasing numbers over the last couple of years, network path optimization, and then also just studying general growth aggregation for our various V4 and V6 tables. In addition to that, they're also interested in address provenance, or in other words, where are these prefixes coming from? And there's been about 500 research papers published using RouteViews data. And if you're interested in seeing any of those papers, we have them published here at the link below. So I'm going to walk you through kind of what I kind of refer to as our first generation data distribution model. And as we mentioned before, it's a file-based format, and it's based on an RFC standard called MRT. So that MRT data is essentially asynchronous. You need to wait for the collector to dump the RIB or the update file, and then zip it and sync it back to archive, where then you as a user could go grab that data and analyze it. That's a manual process. You need to do the retrieval yourself. If you need to do any sort of sequencing in terms of taking 2 MRT dumps from different collectors, that's all done manually. Same with consolidation. There's no post-processing, so we aren't going through the MRT dumps and filtering out any sort of RFC 1918 or null or default routes. Essentially anything that's advertised to us ends up in those MRT files. And it's a centralized model. Essentially the place that you can collect or retrieve this data is a single server at the UVO that we mentioned before, archive.routeviews.org. We do sync it to some other places and have some other distribution models, but by and large, that's how an end user would go about retrieving that data. And as you can see, this is not, it's not an ideal process, right? There's some things that certainly could be improved upon here. There's some workflow issues that we could certainly address to make this easier for both the research and network operations communities. And that's really what inspired this second generation of our data distribution model. So that is a message-based distribution model where we have per message timestamps and metadata that comes in with each message from the collectors. We have automated consolidating and sequencing. We're working on database storage and access to that data, and also RESTful interfaces into that data. But those are still projects that we're currently working on and not necessarily ready to release to the public here. And this is also real-time streaming data. So as those update messages are being received by our collectors, they're being streamed back to our collection point, where then they can immediately be consumed by anyone with a client to read that data. And we're going to talk about that and actually give you guys a couple of examples of that towards the end of the talk here. And then finally, we have this idea of a middle layer abstraction. So if we think about what that looked like in the previous generation, everyone had to go to our data archive site to grab those files and sync them back to their local host, where they could then run whatever analysis or troubleshooting they needed to do. In this model, as you guys will see in a minute, the client doesn't have to worry about where the messages are being synced from, where the collector is located, what servers are sitting in between to essentially facilitate the data retrieval process. It's just about, can my client read this data, and do I know the interesting parts of the data that I want to look at? So before we go into anything further on the second generation side, we're going to jump into a couple of just basic how-tos in terms of how you can use RouteViews as a network operator. And one thing that I will point out here is that we do have a interactive map of our collectors that gives you a geographic view of where they're located, some of the features that they have enabled, the OS and the type of collector that it is, and the different exchanges that they're on. And I'll give you guys a sample of that towards the end of the presentation as well. So some common use cases that most network operators are familiar with, but maybe don't think about using RouteViews for. The first one really is, what routes am I advertising? That's a common use case where getting a third-party perspective or an external perspective can be extremely useful for you. So if you're familiar with a iOS-like command line, you're going to be familiar with the RouteViews command line, which immediately gives you a leg up in terms of troubleshooting. So if we wanted to, for example, look for the specific prefixes that are being advertised from an AS, we would do something as easy as show IP, BGP, regex or regular expression, and then your AS with the underscore and the $sign there at the end. That's telling us to show all of the prefixes, essentially with this specific AS at the beginning of the path. Another one that we see a fair amount, and we'll also touch on a little bit later as well, is, so what's the best path to a prefix from a RouteViews perspective? Well, that's a similar command. So show IBGP, IP, BGP, the prefix you're looking for, and then the best path command. So another thing that we see a lot in terms of interactions with our network operations group is, what collector am I peered with? And that can be difficult at times just based on, we're at an exchange, but you don't necessarily associate a name with that collector at the exchange. So the easiest way to do this is to, if you're a CLI person, is to just curl this HTML peering status page and simply grep for your AS. And you'll see essentially right next to your AS, in addition to the peering status of your session, you'll see the collector that you're peered with. Okay, so those were kind of the general use case examples that we have. Being that this is a MANRS Tech Talk, I thought it would be a good idea to talk about RPKI. So RPKI, as many of you probably know, is short for Resource Public Key Infrastructure, and it's a public key infrastructure framework designed to help secure the internet's routing infrastructure. RPKI provides a way to connect internet prefixes and an AS in a trust anchor relationship. Essentially, it's a mechanism to validate the prefixes coming from the ASs that we see within the global routing infrastructure. So kind of just a quick general overview of what that looks like from a conceptual standpoint. We have AS 65001. They're going to advertise 10/8. We're going to sign that AS and prefix combination, and we're going to hand that off to our RIRs. They will then help us cryptographically sign that data, and then we can rsync it to an RPKI validator cache. These validator caches speak to our routing platforms, and in this case, they speak to our RouteViews collectors and provide us a view of what is RPKI valid invalid, or just not found within the table. So RPK on RouteViews, as I kind of touched on, is essentially all of the modern FRR collectors that we have out there have RPKI running on them. That's not to say that they're actually filtering on RPKI state, right? The intent of RouteViews isn't necessarily to filter out anything that's in the global routing table. It's to give you a view of what's being advertised to us. So we don't filter or drop any routes based on their RPKI state. So a couple of additional how-tos, more specifically geared towards RPKI. The first one is, so what's the state of my prefix within, or how does RouteViews view my prefix within the global routing table? So to do that, we would do something like show RPKI prefix and then the prefix you're looking for, and you will see either a state of valid, invalid, or not found. And if you want to look at the whole RPKI prefix table, you can do show RPKI prefix table, and you'll get the full CLI dump of that command. And to get an understanding or gain an understanding of what collectors have RPKI turned on, go ahead and go to that map link as well, and you'll see that there's a flag there to essentially filter by the collectors that have RPKI enabled. Okay, we've also been working on exposing some of this RPKI data through APIs that RouteViews provides. So one example of that you could also use would be to essentially curl this this URL here. As you can see, we're looking for 1.1.1.0/24, and we get an answer back with the ASN that's advertising it, the RPKI state that is in the RPKI table for that prefix, and the timestamp that we last validated that state. Another way that we could look at this is you could also curl for the ASN and get a list of prefixes specific to that ASN and their RPKI state. These entries are generated off the MRT rip dumps. So essentially this table is refreshed every 2 hours in the API. And if you want a full dump of valids, invalids, and unknowns, that's available just at the base URL there. And just a word of caution, that's a pretty large JSON output. So it's probably gonna take a minute or two for it to build that whole thing. Okay, BMP. So this is basically the foundation of our second generation data distribution model. So what is BMP? BMP is the BGP monitoring protocol. It's an RFC standard through the IETF, and it's widely supported on many, if not all, of the major routing platforms at this point. It's also supported in FRR, which is what our RouteViews collectors are based on. In addition to MRT attributes, BMP also adds a session start and stop between the BMP server and our RouteViews collector. It also gives us a peer up and a peer down message in terms of when our peers either are established or shut down, or any issue that caused that peer to go down. We also get collector identification, and we get BGP statistics via BMP as well. So the second part of this distribution model is OpenBMPD. That's an open source project through the Linux Foundation, and it allows us to consolidate, as we spoke about a little bit before, to consolidate our peers and collectors into data streams, essentially. So we split those collectors and peers and update messages into those separate streams, also known as topics, which we'll touch on here in a minute. And then the other part of this is the Apache Kafka project, which that essentially comprises the message bus between our OpenBMPD servers and the client that you as network operators would use to view that data. And what's nice about Kafka is it does a great job of addressing the producer-consumer problems that we have in RouteViews and that many pub-sub models have in general. It's been proven to scale really well. It has a very mature client API. So there's over 16 different languages, programming languages that you can get a Kafka client in. So if you can program, you can find a way to consume this data yourself. And it can easily be extended to meet further needs or future needs, excuse me. And so here's a basic overview of what that data flow looks like from a RouteViews perspective. So down here, we have our RouteViews eBGP peers. They're peering with us via BGP. As those BGP update messages come in, they're being encapsulated in a BMP message and then sent to our OpenBMP servers. Those servers then do a little bit of data manipulation in terms of adding some headers and some other useful data, and then they push that message into a Kafka cluster. And then as you can see here, that's where your application would then be able to consume that data. We also can mirror that data to another Kafka cluster if you have that type of a need where you could consume from your own local Kafka cluster. So let's talk a little bit more about what we mean about Kafka topics. So Kafka topics are essentially a category or a feed name to which messages are stored. OpenBMP uses 3 types of topics. You're really only going to be interested in one, so there's a collector topic which has information about the OpenBMP collectors. There's a router topic which has information about router state, which is the up, down name, excuse me, and version of the router. And then there's a BMP raw topic. And essentially that's what we're after here is those raw messages. So the BMP messages are grouped by the collector group, followed by the router group, followed by the peer ASN. So as you can see here, our collector group for all of these is going to be RouteViews. The router group is going to be specific to the exchange that collector, the RouteViews collector is at. And then we also have the peer ASN in that topic as well. And what's really cool about this is that Kafka allows you to use regular expression patterns to subscribe to topics. So essentially what we can do is something like this down here where we have a regex pattern looking at AS 16509. If you guys are familiar with that, that's Amazon's ASN. So essentially we can subscribe to all of Amazon's peerings with RouteViews and see what's happening or see what Amazon is advertising to RouteViews. We also have a way to just subscribe to a specific set of collectors like our multi-hop collectors. So this becomes extremely flexible in terms of network operators that are peered with RouteViews that want to look specifically at their data or really any other data coming in from another ASN. So let's kind of talk about the tools that are available to consume this BMP data. The one big one that I would recommend that folks use is CADA's BGP stream tool. And CADA is the Center for Applied Internet Data Analysis. They're based out of the University of San Diego, and they do a lot of work with the RouteViews data, and they've done a really good job of developing tools for both the research and network operations community. If you're not interested in using those CADA tools, there is a list of languages that are supported or that have a Kafka client. And you will be working on essentially writing your own BMP parser. So just keep that in mind as you start to look at that path in terms of a solution. So another how-to, just to give you guys an example of what that BGP stream looks like. This is BGP Reader, which is the CLI front end to the BGP Stream library. And as you can see, there's just a couple of simple flags that we can use here. The first one here is telling it what project we want to consume the data from. That's the RouteViews Stream project, which is where the BMP data is. I've told it what RouteViews collector I want to essentially filter data on. And then I get this output, and I won't go through all of these different fields, but I'll touch on a couple here in terms of we see an update, and I guess I should say that all of these different fields are obviously delineated by a pipe here. So this line that we're looking at is a BGP update message. It's an advertisement. We have the timestamp. It's coming from the Fortaleza collector in Brazil. The peer AS is listed here. The peer IP is listed, and then we have the prefix, or excuse me, this is the RouteViews peer IP. Then we have the prefix being advertised. We have the peer IP address. We have the AS path. And in addition, if we saw a community that was advertised with that BGP message, we would see that here. So in a very succinct format, we're able to view a lot of data that's coming in live from BGP Reader. And I think one of the things that I really like about BGP Reader in terms of the command line, network operators such as myself, we still rely on the command line for a lot of things. And this still gives us an opportunity to use those, those tools that we're used to using for whatever purpose, in terms of grep or any of those things that you can pipe this output through and really start digging into the data that you're looking for. Here's just a couple of flags that are useful in the BGP Reader CLI. We can filter by the router. In this case, that's the RouteViews collector, the peer ASN, the origin ASN, the prefix or the community. So kind of getting back into those network operations scenarios, if you're doing maintenance and you have an expectation of seeing a specific prefix or a change in an AS path, or even making sure that you're seeing the different prefixes that are coming out of your AS, you can quite easily filter on those things and just see a live output from that tool, which I think is pretty cool. So a little bit more about BGP Stream. And I'm actually going to jump into a demo here real quick, but so libbgp stream is a C and C++ API. So if you're a C or C++ programmer, you'll be familiar with those constructs. There's also a Python API that is essentially a wrapper for the libbgp stream C API. So you can get this in a much more user-friendly Python interface. So we have some PyBGP streams examples here. I have those up over here, and I'll see if I can I drag this over? Oh, it's not going to let me. Hang on, let me stop my screen share real quick and then reshare that. Sorry. Oh. I see what's going on. Sorry, 1 second here. Okay. Let's do this again. Can you guys see my screen again?
Yes.
Yes. Awesome. Okay. So a couple of quick examples. We'll do BGP Reader first. So as I mentioned, or as we saw on the slide, we can throw a quick RouteViews stream as the project. And if I just let this go, let me make that a little bigger for you guys. It takes a little bit to get the Kafka session set up. But as you'll see here in a second, we start getting a whole lot of data, live data coming in from all of our different collectors around the world. And as you can see, there's a lot here, right? So this is really a lot of live data coming in from our infrastructure all over the place, which I think is pretty cool. And as you can imagine, using grep or any of those tools to kind of massage this data is pretty straightforward. So the PyBGP stream examples, I have a couple here, and these are the same examples in our GitHub repo. If I want to look at this first example, you'll notice that there's very little code that we actually need to use to get this going. I mean, I think this is about 20 lines of code, and then you can start applying whatever business or network operations logic that you want to this data that's coming in. And I don't necessarily need to run this example because it's essentially doing the same thing that we're doing here with BGP Reader, but I will show you this other example here that kind of combines two of the things that we talked about today. So this is essentially taking the PyBGP stream library and combining it with our RouteViews RPKI API interface. So if I go ahead and give that a run, and give it a second to get started here, we'll see that we start getting a bunch of data coming out for each specific prefix that we're seeing advertised, the ASN that it is being advertised from, and the RPKI state. So as you guys can see, there's a lot of, actually, I'm kind of surprised because there's a lot of valid state in here, but there's also still a lot of not found, or otherwise known as, these are prefixes that have not been registered with RPKI ROA yet. So I think this is a good way of essentially seeing where we are in the network operations community in terms of RPKI rollout. Okay, so those would like some quick examples there. Let me get this going again. Can you guys see that again? I hope so. All right, and so towards the end here, I just wanted to highlight that we do have an FAQ that covers a lot of the things that we've talked about here today, in addition to some basic things in terms of what we need to stand up a peering with you, where you can find data. So I would urge you, if you're interested in peering with RouteViews or just interested in the project in general, to go ahead and check that FAQ out. And then finally, I wanted to essentially extend a big thank you to the network operations community. Without you guys and the data that you provide the RouteViews, none of this would be possible, and we wouldn't have a thriving research community that's helping us solve some of these problems as well. So I really appreciate the community contributions that are provided through the network operations community. So thank you. And then last but not least, I'm actually going to show you our RouteViews map because we did refer to it a couple of times. And essentially, as you can see here, we have all of the geolocations for our collectors. And you can go ahead and filter on those collectors based on, are they RPKI enabled, and see the collectors where we have that enabled. You can do the same thing for BMP. You will quickly find out that essentially all of our FRR collectors are, RPKI and BMP enabled. And we're slowly working on these older Quagga collectors, getting them replaced and refreshing that hardware. So if you're interested in where we are at from a geolocation perspective, this is a great resource for you. We also have some interesting data here in terms of peers by region that might help inform some of your theories or troubleshooting. And then we also have peer counts by region as well. Or excuse me, these are just peer counts, I believe. So a lot of good, useful data here if you're looking to get involved with the project or you're looking to analyze data from a specific location. The map is essentially the place where you would want to go. And with that, I'll switch back to the presentation and just stop sharing. And yeah, I think we have time for some Q&A, right?
Absolutely. Thank you so much for that, David. We
Cool.
do have some questions coming in, so I'll start asking those. Both of you and Philip has to be on the edge now. One question is, what does it take to host an infrastructure that can host MRT data? A team from University of Dodoma is driving the MANRS initiative in Tanzania and would be interested to collect MRT data in Tanzania and Africa.
That's a good question. So the main thing that you need in terms of hosting MRT data, and this is really going to be based on your requirements, but the big thing is storage. As I mentioned in the first slide there, we have 32 terabytes of compressed data that goes back to 97. So if you, for example, wanted to host that data locally, you would need at least that much storage to do so. And then obviously, as you uncompress that data, it grows, to be quite large. So that's the biggest piece. And then the other piece of hosting this is, you're going to need some of those basic infrastructure pieces like Apache, Linux, some of those Linux command line tools that allow you to rsync data. But really, there's not a lot there in terms of what you need to start pulling that data down and hosting it locally. And please reach out to us if you want to do that so we can help facilitate that.
Right. So more question coming in. So this one from Simon Green. Is there any alternative way to use RPKI for filtering if the router does not support RPKI RTR? So that's there are some router OS available.
That's a really tough one.
Yeah. So what you can do, what I can think of is you can use an RTR client, take a dump, and then convert it into a prefix filter. Okay, Philip, I'll punt it to you.
Well, that was pretty much, when Simon asked the question, that was pretty much thinking. I was thinking back to old days of, sort of building static routes to null by hand based on, kind of the early thing before the Team Cymru's, BGP feed of all the bogons. It was building something like that by hand. But of course, the scary thing is building by hand, you've got to maintain it all the time. And, the RPKI data is changing all the time. People are signing things, they're stopping signing things, they're signing, subnets and changing their minds and so forth. So, it really more a case of pressuring your vendor if they don't support RPKI on the routers, to pressure them to make it available. And at least we're lucky that most vendors are there now. But I mean, gosh, the last, what was it be? It'll be 10 years, 8 years now. There's been a fair amount of effort to persuade the vendors that this is actually important.
So I just looked up how many invalids are there in the global routing table, and there are 2,364. So that means that would be 2,364 lines of prefix filter.
I mean, it's it's certainly doable, and it's Terry Sweetser has commented that HE was doing something like this as well. So not using RTI, but actually building something alternative. You can do it with scripting and so forth. If you've got the confidence and ability to do it, you could, but I don't know. I'm more the router guy, so I'd be like, I would be much happier if my equipment could handle it.
Okay, so Simon, let me take this one as a personal assignment. I'll put up something as a quick Python script if I can do something for Cisco and Juniper, because these are the two platforms I use internally in my lab. So if I can do something, because I already collect the prefix and the ASN, it's just you have to create in a nice prefix filter format. So yeah, I'll share it once I'm done over the weekend. That's a good one. Cool. If it's gonna melt my router or not, I have no idea. It's 3,000 line. I think it can live with it. So because you have to update it as early as possible, otherwise people will start yelling at you that why you haven't updated your prefix filter. Right. So going again, Amrish. Oh, good to have you, Amrish. From Afrinic, how can we help you increase the number of collectors, especially in Africa? What is the minimum requirement for a VM or a hardware?
That's a great question. So let me see here if I can. Well, I'm not going to try and share my screen again. But essentially, those requirements that, or they weren't requirements. Essentially, the hardware that we use to deploy a RouteViews collector, which is the 8 to 16 CPUs, 32 to 64 gigs of RAM, 400 gigs of disk, and essentially an interface into the exchange where we're going to be connecting there in Africa, or whatever exchange in Africa, and then an interface for transit that we can allow people to telnet into that RouteViews collector. Those are the only things that we need from a VM perspective. And we much rather prefer VMs because it just makes the overall maintenance for RouteViews so much easier, and also for the hosting provider, right? So if all possible, we'd love to see a VM there. And please reach out to us at help@routeviews.org if you have some ideas in terms of what exchanges you'd like to see in Africa that aren't currently have a RouteViews collector at them. That's a great question. I'd love to work on that.
Okay, perfect. Amrish, I'm pretty sure you'll be working with RouteViews to add more collectors in the region, because that the map shows there's a lot of collectors in not just Africa, South Asia as well. So we have to work on that. I hope somebody, at least Anirban is there, and who can look at, GC Kabir is there, so probably they can help us out as well. So another question coming up is, do I have to download all the BGP dumps in order to look at the data? If I'm troubleshooting a past incident, then what should I look at first? Full table or just the updates?
Yeah, can you guys hear me okay?
Yep. Okay.
So that one's kind of tough, right? So it depends on if you know where your issue is regionally or globally, or if you need a perspective from outside of that. But I would assume that as long as you know, and Philip, please correct me if I'm wrong here, as long as you know when your issue started, that's really what the RIB and update files that you're going to want to start with, and start combing through those prefixes and AS paths to figure out what changed.
Yeah, and as always, Philip suggests that make sure that your timestamp is in UTC, so you're not looking at the wrong time zone.
Yeah, and that your timestamp is actually your clock is connected to a time source that's actually correct, rather than just whatever it was when it powered on, which seems to be all too common as well.
Yes, and I've seen it so many times, because the BGP shows you the epoch time, which is very granular time. If you don't know when it actually happened, then you will not be able to figure it out. Another one is RIPE-NCC BGP Play uses their own collectors. If I want to use BGP Play with RouteViews collector, then how should I do it?
Yeah, so we have an old instance of BGP Play that I will openly admit that we need to modernize and upgrade to allow folks to use, because it's not in a state that is going to be usable for folks right now. But we do support it. It just needs a little bit of care and feeding on our side. And the URL for that is bgplay.routeviews.org, but again, it's a little outdated.
All right. So, but you can still solve the BG Play locally with all the dumps you have installed.
Yes. Sorry, I didn't really think about that kind of model. Yeah, that should absolutely be possible.
That's just 32 terabytes of data to download.
Well, maybe start with a smaller chunk, right?
Yes. Right. So another one is from Christopher Bowie DeSoto. Would this be the best data source for using machine learning AI to identify bad route announcement and repeat bad actors?
In terms of a data source, I would say that I'm going to say yes, because you don't have a lot of options. I think the issue is going to be, if you're looking at any sort of AI or ML application, is how do you shape this RouteViews data in a way that your data models can essentially parse it and identify any sort of bad actors and reinforce on that. But in terms of longitudinal data, it's really us and RouteViews if you want to start looking at those things. But most of this data in terms of routing archived data is going to be in this MRT format. And I've always thought it would be really cool for someone to do this and then apply it to the live stream of data. So you actually have a real-time AI ML application looking for bad actors in the BGP routing infrastructure.
Perfect. So again,
Cool.
I wanted to Philip on this. It's just a follow-up question that regarding UTC, are you suggesting that we set the router log timestamps in UTC?
Well, it's really up to what you want to do. And if you're operating in one time zone, you can run it in your own local time zone. I mean, there's no real need to go to UTC, but a lot of people just use UTC as a matter of course. If you're running across multiple time zones, set everything to one time zone. And again, industry practice just seems to be UTC. And it's probably the most sensible thing to do in that it's predictable wherever you are logging in from around the world. So yeah, it's just really what you want to do is what I would be suggesting. So multiple time zones, make them all UTC. If you're just operating in a single time zone, you can use your local one or just make it UTC.
Perfect. So another one is, so David, you mentioned about the options. So there was an NL nog ring also has a many collector. Is there any difference between NL nog ring and RouteViews?
Yeah, so, and I have a limited understanding of NL nog ring. I'm not a participant in that, but my understanding is there's command line tools that NL nog ring has that are more focused on data plane troubleshooting, so ping, traceroute, etc. But they do have a router looking glass that uses the open source routing platform Bird. And then they have some router proxies that are attached to those Bird instances at some of these NL nog ring locations. But those are separate from our RouteViews infrastructure. It's a really cool model in terms of what they've done, but they don't overlap in terms of RouteViews and NL nog ring.
Yeah, perfect. Another one is with ROV, with route origin validation implemented by many operators across the globe. The global routing table see from one of the global routing table I see from one of the route dump from RouteViews collector is not going to show any invalids or some invalids. How do I find the complete list of invalids present in the routing table?
Yeah, that's another tough one, right? Because if any of our peers are doing RPKI validation, we start to lose that data potentially, right? So I would think the best way to do that would to essentially, well, so there's two things that we could do. And one thing that we've talked about doing is essentially setting up two collectors that are just dedicated to doing RPKI state. So we would filter on invalids and dump that data into an MRT format. And then we would do one for valids and dump that data into an MRT format. Outside of that, but we still suffer from the same problem, right? Where depending on where we're getting that feed from, if there are RPKI filtering, we might not see those invalids. Aside from that, we do have a route map on our modern FRR collectors that keys off of the RPKI state. So for example, you could run show IP BGP route map invalid, and that will dump the invalid prefixes that collector is seeing. So that's probably the closest you're going to get. And again, it's going to change collector by collector, peer by peer.
Yes, okay. So that is still challenging because we don't know. But my point of view is, if you are seeing few invalids, it means whoever your peer is not filtering. So it means you should be seeing almost
Right.
all invalids. So
hopefully none, but yes.
Good.
The more invalids you're seeing, the higher likelihood that the folks that you're peering with are not filtering those.
And that's the nice thing about checking over multiple collectors as well, which is what I do quite a bit. In some places you know the invalids have been dropped out, and you're getting the full feeds. But I go to quite a few other places. But I don't think we can find out every single invalid in the whole global table anyway, because the routing table looks different wherever you look.
Right.
So, but you certainly get a good measure by the time you go over all the RouteViews infrastructure.
Yeah, that's a good way of finding the invalids. But if you are doing it on the real time, that I think just stick with one, maybe, or maybe the BGP Kafka updates, because that is where you can get the real time update if it is an invalid or not. So again, the example you have given, maybe we can tweak it a little bit and just grab the invalid and see what is there.
Yeah, absolutely.
Yeah. So on the last topic of the RPKI validation, Philip, what do you, so before that, I just need to ask one thing, David. Which RPKI validator you are using?
Oh, was that to me or
to
Philip?
Yeah, no, to you.
Oh, so right now we have two, and essentially we did two different flavors, we'll call them, because RPKI was relatively new still. The validators were, I would say, still in flux in terms of stability and whatnot. But we started with RIPE-NCC's validator, which they have recently announced that they're sunsetting. And then we're also using the, Philip can tell me who's doing this one, but RouteViews.
Yeah,
I can't remember.
NLNet Labs. Yeah.
Yes, thank you. So those are the two that we're using, and they've both worked really well for us. And then of course we're going to have to find a suitable replacement for the RIPE-NCC validator here at some point.
All right, that's perfect. And again, to Philip, just to wrap this up, on the route origin validation part, what are the steps you would suggest when somebody wants to start the route origin validation?
Well, are you assuming that people have actually signed their ROAs first? But, I mean, the two things are independent anyway. But, I would always say the first thing is get your ROAs signed. But, assuming all that, if you want to start with doing the validation, obviously you need routers that will support it, which thankfully is most of them these days, at least the most of the modern operating systems. And then the next thing is I won't sort of plunge in and just throw away all invalids by default. So Cisco IOS default and IOS XE is to throw away invalids. So you don't really want to do that. At least I would caution against doing that. Simply, I would rather set up your router to talk with, so all your eBGP speaking routers to talk with your validator cache and just see what it's doing, see what it actually flags as being invalid. But don't throw it away, because you may end up throwing away something that's actually really important for your customers or your end users. And they may get a bit upset if there's, if the routability or reachability becomes suboptimal or disappears altogether. So actually have a look and see what ends up being invalid, and run with that, whatever your standard period is for testing new deployments in your network infrastructure. I tend to throw caution to the wind, let it run for a week, see what happens, and yeah, looks good, we go for it. But other people are more testing for a month or 3 months or something. With validators, I would always get 2 validators up and running. Luckily so the NLNet Labs RouteViews, Nick Mexico's Fort and Cloudflare's validator are all very, very simple installs now. You can do apt-get install for all three of them. So it's so laughably simple. Because, in the last few years, it was always the big story of how to compile them all and trying to get libraries and which OS, and then this package and that package was a bit of a mess. But now that's just, at least on Debian SOAP-based ones, it's an apt-get install for all three of them. Have two running. Just the whole redundancy thing, I prefer at least two of everything. So have two running, and then get your router, your eBGP speaking router, start with one, get it talking to two validators. You can see what the RPKI table looks like. Don't throw away invalids until you're satisfied that what's going to be thrown away is not going to be service impacting. And then once you're satisfied, then you can just turn it on, throw away invalids. With not founds, those are obviously folks who've just not bothered to sign any ROAs. You could penalize them if you want, but I don't know, I'm two minds about that. Some people will say, yes, local pref them low. Others are like, well, yeah, they'll get around to actually doing the signing. And of course, with the valids, life goes on.
Right, perfect. So just my last question, very interesting one popped up from Zubair, asking, in RouteViews feed, should a feeder send a /32 receive from a downstream for the RTBH, for the remote trigger black hole as well, though the feeder is not announcing those to outside? We see this problem in the BGP stream all the time. So what do you reckon about this one?
Yeah, typically when we when someone comes to us and says, hey, I'd like to peer with RouteViews, what we tell them is, okay, if you can, send us a full routing table minus any sort of default RFC 1918 or null routes. So those /32s that I assume are being routed to null, go ahead and filter those out. Obviously, as you've found, some people don't do that. And we kind of have to take this approach of once it's in the data, it's in the data, because we don't necessarily want to get into the position where we're determining what routes should or shouldn't be in that data, right? If we try and filter it on our side. So we kind of just have to say anything that you advertise to us is making it in the data. So they should absolutely be filtering those things.
Awesome. This is just a wrapping up question, and I'll just give it to Philip because he's going to love it. Can we propagate RPKI state internally within an AS through IBGP, meaning one router gets state from the validator through RPKI RTR protocol and propagate the learned information onward? Would it be a good practice doing so?
Oh gosh, yes. Well, we had a whole RPKI deployathon at Apricot in Melbourne last year about looking at that, didn't we? Okay, I'll share my preference based on horrible, bitter experience, and it's basically, please don't do that. And I would much rather have all eBGP speaking routers talk to the validators and dropping invalids there and then, rather than trying to propagate information about invalids across the networks. And again, it comes back to Cisco IOS and iOS XE doing really bizarre stuff. If a validator disappears, the way it holds on to routes, or dropping validation state and then propagating wrong validation. Anyway, it's a long, big mess. So I would really, please don't do that at this moment, at least until all the vendor stories are properly tidied up. I think that's probably the simplest way of explaining. Set it up, eBGP routers to speak to the validators, and then you'll keep yourself out of trouble.
Yeah, I still remember the Melbourne fiasco. We had a very long discussion because, this is a very common scenario in many operations because they have multiple eBGP session, talking to multiple transit and peering, and they internally share everything via IBGP. And that's why we can just speak to one validator and then it propagates everywhere. And we tested it, it wasn't a good picture. And so, yeah, so again, go with Philip's advice, don't do it. Every edge should be speaking to the validator. So on that note, we have to thank our guest, Dr. Philip and David Teach. David, thank you so much for staying up till midnight. I think it's way past midnight now. So thank you again. Hopefully people have learned a few new things. So, and they will be reaching out to you as well. So thank you so much.
Thank you guys for having us.
Take care. Bye-bye.
Thank you very much.